Okay, so lecture 13 is on trigonometry, and this is because we need to graph things. What we'll need to be able to do is graph trigonometric functions, so we're going to do a little bit of review of this. So we're going to look at graphing trig functions with variable amplitudes, condensing things of this form into things of this form, and then condensing things of this form, and that should actually be an A here. Need the same coefficient on these two into that form. So first we'll start by graphing trig functions with variable amplitudes, because we get functions like this when we solve second order ODEs, and we want to be able to graph those sorts of things, exponentials times cosines. And we want to think of this as an amplitude, the e to t as an amplitude. So if we want to graph a function f of t cosine omega t, where omega is some constant, we know that cosine varies between -1 and 1. So if we multiply through by f of t, forgot to put the f of t in here. Then we know that minus f of t is less than or equal to f of t cosine omega t less than or equal to f of t. So we just take this thing and multiply through by f of t. So the graph of f of t cosine omega t oscillates between this graph and this graph. So this one's actually got a constant amplitude here. So what do we know about cosine? We know that -1 is less than or equal to cosine of 2t is less than or equal to 1. So if we multiply through by 7, get this set of inequalities, and so then we can graph it, or at least sketch a graph of it. Remember that the 2 here means that you have 2 cycles in 2 pi, which means that you have 1 cycle in pi. So if we put pi here and 2 pi here, we have a graph that will oscillate between y equals -7 and y equals 7. So we'll put in 7 and -7, and we do a complete cosine cycle from 0 to pi, and then another complete cycle from 0 to 2 pi. So there's the basic graph of 7 cosine 2t. And then it just keeps going with that same spacing. Right, so the amplitude is sort of the bounds of the function and oscillates between the 2 amplitudes. Okay, what about e to the 2t cosine 4t? Well, we know that -1 is less than or equal to cosine of 4t is less than or equal to 1. So multiply through by e to the 2t. And you get that. The 4, that means 4 cycles in 2 pi, which is 1 cycle in 2 pi over 4, which is pi over 2. Like that. Okay, so what does the graph look like of this thing? Well, we'll take, here's our t-axis, here's our y-axis. Y equals e to the 2t, goes through the point 1, and looks like that. Minus e to the 2t. Oh, did that backwards, sorry. That's e to the minus 2t. E to the 2t goes through that point and goes up like that. That's y equals e to the 2t. Y equals minus e to the 2t. Looks like that. Okay, so from 0 to pi over 2, we get 1 cycle, another cycle to pi, another cycle to 3 pi over 2, and then another cycle out to 2 pi. Extend this a little bit. So cosine, a cycle of cosine starts at 1, goes down and back up, and then down to this graph and back up to that graph. Then the cycle goes down to that and up to that, down to that, and up to that. And in backwards time, it does the same thing. It oscillates between the two exponential functions because those are the amplitude. So it's a graph of an exponential times a cosine function. An exponential times a sine function is very much the same sort of thing, right? So the variable amplitude, you draw the function and it's negative, and you draw the trig function in between. What about this? Well, this part does 1 cycle in 2 pi. This does 10 cycles in 2 pi. So we're going to take this to be the amplitude. It's the low frequency one. It does very few cycles in 2 pi. This does 1 cycle in 2 pi over 10, which is pi over 5. So if we take this as the amplitude, the 5 cosine t, what do we know? We know that -1 is less than or equal to sine 10t is less than or equal to 1. So that tells me that -5 cosine t is less than or equal to 5 cosine t sine 10t. Just take this set of inequalities and multiply through by 5 cosine t, is less than or equal to 5 cosine t sine t. And there's a little bit of an issue here about if you multiply through by a negative number, what happens if cosine t is negative? Everything switches. But since this is periodic, that's actually not going to be a problem. So what's my amplitude look like? Five cosine t. I mean, technically, you could do everything with the absolute value of 5 cosine t. 5 cosine t from 0 to 2 pi does 1 cycle with an amplitude of 5. That's sine. Let me undo that. Cosine t starts here, goes down to 0, and comes back up. -5 cosine t is the reflection of that, and that looks like that. So in 2 pi, we should have 10 cycles of sine. So 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. And sine starts here, so we'll do a complete cycle of sine, and then another complete cycle of sine, and then you get a cycle of sine that gets squished in here, and another cycle of sine, another cycle of sine, and we're halfway through. Another cycle of sine, another cycle of sine, another cycle of sine that gets squished, another cycle of sine, and another cycle of sine. So it oscillates in that way. So let's go to, and then it continues off to the other side. So let's take a quick look at GeoGebra. I don't think I want that picture yet. I want this one. So this is the graph of 5 cosine x sine 10x that we just graphed. And it looks like this. You can see that it's periodic in some way. So my two bounding functions, my amplitudes are 5 cosine x and -5 cosine x. So if I add that to the graph, there's 5 cosine x, there's -5 cosine x. So that's my amplitude, right, is the blue curves. That's the 5 cosine x. And then the sine 10x is the, multiply the blue curves by sine 10x, and that gives you the green curve. So the green curve is 5 cosine x times sine 10x, and it's bounded above and below by the amplitude 5 cosine x -5 cosine x. So that's what that graph looks like. So if we go back to our notes, where's my notes? There we are. Okay. So a cosine omega t plus b sine omega t, right? So same frequencies. We want to turn into a cosine omega t plus phi. Actually, we want to turn that into a cosine omega t minus phi, is what it's going to turn into. And that's because we get these homogeneous equations, right? And the solutions are a cosine omega t plus b sine omega t if you have no friction there. And so we want to graph these to rewrite them like this, where a is my amplitude and phi is a phase angle. So how do we rewrite this? Oops, where's my pen? How do we rewrite this as this? Well, we're going to need that trig identity, that cosine of x minus y is equal to cosine x cosine y plus sine x sine y. So that's a trig identity. So we have a cosine of 2t minus phi. If we use 2t as x and phi is y, and a is just a constant outside, then we get a cosine 2t cosine phi plus a sine 2t, oops, sine phi. So we have that using the trig identity, and we have that we want y equal to 4 cosine 2t plus 3 sine 2t. So what do we need here? Well, cosine 2t has a coefficient of a cosine phi in this equation and a coefficient of 4 there. So we need 4 to be equal to a cosine of phi. And sine 2t here has a coefficient of 3. Sine 2t here has a coefficient of a sine phi. So if we want these two things to be equal, we need 3 to be equal to a sine of phi. It has to be equal to the coefficient on the sine 2t. So how do we go about finding a and phi? We use some trig identities. First one we use is sort of the classic trig identity, cosine squared plus sine squared equals 1. So if I take this equation and square it, I get 16 equals a squared cosine squared phi. If I square the other equation, that's a semicolon there, I get 9 equals a squared sine squared phi. If I add these two together, I get 16 plus 9 is 25, and that equals a squared cosine squared phi plus a squared sine squared phi, where 25 equals a squared times cosine squared phi plus sine squared phi. But the thing in the parentheses is just this is just 1. So a equals square root of 25. To find phi, part 2, if I take these two equations and I divide them, and remember sine over cosine is tangent, right? So we'll take the sine term, which is a 3, divided by the cosine equation. We get a sine of phi over a cosine of phi, which is tangent of phi. So phi equals arctangent or inverse tangent, however, whatever notation you use for that. And in this case, you can use a calculator or from alpha, whatever you want, to figure out what phi actually is. Phi is about 0.644 radians. Don't know why the pen does it sometimes. Or, which is about 36.87 degrees. And this is called the phase shift. So what do we know now? We know that our function for cosine 2t plus sine 3t for cosine 2t plus 3 sine 2t equals a, which is 5. Square root of 25 is 5. Cosine of 2t minus arctangent of 3/4, which is about equal to 5 cosine 2t minus 0.644 radians. Great. So we want to be able to graph that. We have to be a little bit careful about the phase shift. So when we're dealing with a cosine with something like this and this, you have to remember that a cycle of cosine is between 0 and 2 pi. So whenever this goes between 0 and 2 pi, you've done one whole cycle of cosine. You might have done many cycles of cosine actually, but you've definitely done one. So at least one. We have that. And we can solve this for t by saying, okay, we'll add a 0.644 to each side. And then we'll divide by 2. So the phase shift that we actually get, so this is 0.322 is less than equal to t is less than equal to pi plus 0.322. So if this 0.644 isn't there, if we're doing 2 cycles in, if our frequency is 2, that's 2 cycles in 2 pi, which means 1 cycle in pi, and we got that. But it's shifted, and it's shifted not by the 0.644, but by the 0.644 over 2. So our graph is actually going to start at 0.322, and then it'll do a complete cycle from 0.322 to pi plus 3.22, and then at 2 pi plus 3.22, it'll have done another cycle. So a graph actually looks like that, and it goes through the y-axis at some point, and its amplitude is 5 and minus 5. So when we're graphing these kinds of functions, the phi is the phase shift, the frequency is 2, so 2 cycles in 2 pi. But when we're actually graphing it, right, we have to divide the phase shift by the frequency to get the correct shift. Oop, wrong thing. You don't really want to see me. We want to go back to the GeoGebra. And so this is the graph of 4 cosine 2x plus 3 sine 2x. And we found that a should be equal to 5. So there's the graph of 5 cosine 2x. And it's the correct amplitude, and we just need to shift it to be able to get the green graph. And so if we shift that to the right by arctangent of 3/4, we get this red graph. So we'll remove the blue graph there. So there's the red graph. That's the graph of 5 cosine 2x minus arctangent of 3/4. If I remove that, oh, there's the green graph again. So the green graph and the red graph are actually the same thing. And so that tells me that the green function and the red function are different formulas. This f here and this h are different formulas for the same function. Okay, so now let's go back to the notes. And the last thing we want to look at is if we have a cosine omega t plus a sine omega t, with these frequencies are different, can we turn it into this sort of a function where they're multiplied together? We want to be able to do that because then we can think of this as a amplitude, and then this is the oscillatory thing. And we show this shows up when we have a forcing function on the right-hand side of cosine a to t that's different from that number. So you get a cosine omega t plus b sine omega t plus c cosine a to t plus d sine a to t. So graph y equals cosine 14t plus 4 cosine 18t. And we need a trig identity again. And that's cosine x plus cosine y equals 2 cosine x plus y over 2 cosine x minus y over 2. Okay, so we have y equals 4 cosine 14t plus 4 cosine 18t, and we want to adjust this a little bit. So we'll factor out the 4s. And now we've got cosine 14t plus cosine 18t, so we can apply this trig identity with x as 14t and y as 18t. So this becomes equal to, so 4 cosine, always important to keep your equations straight, equals 4 times, inside the parentheses, we'll have 2 cosine of 14t plus 18t over 2 times cosine of 14t minus 18t all over 2. So our function, just move to the left a little bit so we have some space. Cosine 14t plus 4 cosine 18t is actually equal to this 4 can multiply this 2 to give me an 8. 14t plus 18t is 32t. 32t divided by 2 is 16t. 14t minus 18t is minus 4t, divided by 2 is minus 2t. And so we'll do a little bit of tidying to make that in a form we like. Put the 8 here, we'll move this part to be the 8. And we'll write it as cosine 2t because cosine is even. And we'll just note cosine is even. So that means that cosine of minus x equals cosine of x. Cosine and sine have some nice sign properties, SIGN. So great. And now this is the kind of function we were graphing earlier, 8 cosine 2t times cosine 16 2t. We'll take this as the amplitude, and this is an oscillatory thing inside. So our amplitude is 8 to minus 8, and we graph 8 cosine 2t, which will do 2 cycles from 0 to 2 pi. That's 8 cosine 2t. That's my t-axis. This is my y-axis. And then we can graph negative 8 cosine 2t. And then we have, in 2 pi, we'll have 16 copies of cosine crammed in here. So that's going to be a little bit tricky, but the function ends up lots and lots of ups and downs in here. And you don't have to be super precise about how you draw that, right? We want to know what the amplitude, what the envelope of it looks like more than anything else. So if we go back to GeoGebra, GeoGebra, there it is. So that's the graph of 4 cosine 14x plus 4 cosine 18x. It looks like that. It's periodic, but the periodicity is a little weird. So 8 cosine 2x, we found out should be the amplitude. And if we put that in there, there's 8 cosine 2x, there's minus 8 cosine 2x. And so this function does 16 cycles within the blue boundaries. And this is a little bit crowded, so let's zoom in a little bit so we can see what we're looking at. Oh, I don't want to do that. Zoom in. Well, let's keep the amplitude correct. There we go. So you can see it a little bit better there. Maybe we'll change the x-axis a little bit. This thing. Settings. Let's make the x-axis go from 0 to say 14, because 14 is definitely bigger than 4 pi. Oh, what the heck? Well, now it's decided to quit on me. That's annoying. Be back. Nope, this one has decided to quit. Okay, so, but that's the graph, and you can see that these two functions here are actually the, oh my gosh, that's terrible. Did not want to set x max to 14 billion or something. And now it won't let me change it. So, and that allows us to graph these sorts of functions without having to so condensing these things like this, which is a kind of thing we get from a function like cosine a to t and then an omega squared, we can see what those kinds of solutions look like. Okay, so that's that.